You have find probability that the event A occurs or event B occurs but not both. Oh, okay. You need to interpret this lah. You don't want both to exist, so it's in other words, you want this one here. A occurs or event B occurs but not both, right? So you don't want both to occur at the same time. You want this part here. Alright? This should be the one that you're looking at. But not both at the same time. So what we do is we just take PA union B, which is actually PA plus PB minus PA intersect B. Just find this level 20. Two-fifth. 7/10. Okay, then PA required probability. PA union B is 7/10 minus of 1/4. Which is 9/20. Okay, let me just do part 2 first. Find probably the event B occurred but not A. So B occurred but not A will be this crescent here lah. B occurred but not A is this one here. So essentially just write down part 2. PB intersect A prime is PB minus PA intersect B prime. So PB is actually 2/5 minus 1/4. 2/5 minus 1/4 3/20. Part 3 for third event C is given that PC is half and A and C are independent. Now this is where you need to take note. So you when A and C are independent, meaning between A and C they have a fixed relationship, fixed area between them. What is not fixed is between C and B. Okay, this is like a triple thread. It's a relationship, right? They have A, B, and C. Between A and B is fixed. Between A and C is also fixed, the relationship. But what is not fixed is between B and C. Okay, because A and B, you have 1/4. A and C are independent. So that's the whole idea there. So what I usually would recommend for this case here is you draw out A and B first. Okay, you don't care about C first. You bring C later into the picture. So usually what I'll say is just draw this out and we use what we had just now. So A and B here. So we had B intersect B A prime would be 3 and 20. So it's 3 and 20 here. Okay. Between A and intersect B prime, A intersect B prime is 1/4, right? We found all this. This is 1/4. Then if you want to find A union B is 7/3. So outside here is 3/10. So just find all the areas out first. Don't care. Just find it out first. This is what I recommend. Just find all this out. So it's 3/10 as well. So once A and B's relationship is established, you know that then only you bring C in. And you bring C inside. But between C and A, the relationship is fixed. Okay? So this is C. Let's say this is C. This relationship is fixed. So in other words, right, your C here, if you can imagine this with me, follow me very carefully. This C can freely move in and out of B, or can even be mutually exclusive. Mutually exclusive like here. where it doesn't touch B at all. You know what I'm saying? So there are a few different cases there. But what you need to do is actually just find this potato here. This potato is important. What we want to find? We want to find A prime intersect B prime intersect C. Okay? B prime intersect C. Okay, so means we need this side here, this outside later. So anyway, we find this property of A intersect C prime here. But because A and C is independent, it's PA times PC. So PA is actually 11,120. PC is how much? PC is actually half. So this is 11/40. It's 11/40 here. Okay, so meaning outside here, no matter what happens here, outside would be PA prime intersect C would always be C, which is half minus 11/40. I'm just settling the relationship between A and C first. So this is 9/40. Okay. How much? Okay, 9/40 is what is 9/40 here? So you must ask yourself whether this crescent here can fit inside here. Can it fit inside? Can it fit inside? 3/20 is how much? 3/20. Cannot, right? This is 0.15. So 9/40 is actually 0.225. Okay, so at the very most, right? C can only swing in. So let me just draw A and B here. Okay, this is C. Can only swing in, right? Where B 3/20, right, is totally inside here. So what is this point here? Because we want to find mean of A prime intersect B prime. So it's AB. A prime intersect B prime intersect C, right? A prime intersect B prime intersect C is where? Is actually here, right? A prime intersect B prime is there, right? Right. So what you need to do is actually this mean here. When you move this inside, right? Is because this case here, no matter what, this area here, outer layer here, is actually 9/40. Okay, so this half a potato here is 3/20. So this would be 9/40 minus 3/20. In calculator, you get 9/40. I want to check whether the outside can accommodate 3/10, can accommodate 9/40. 3/10 is actually 0.3. You can, right? So essentially, you can have another case here where this is C, this is A and B. This will be 9/40 outside. So max. So hence because this is where we want to find.